video in the real life. You observing when you look a white billboard into the second. The red one sitting on the table. They hit each other in the right way. What happened after the collision? You lead.
Teacher, I think that after they hit each other, they will move in the different directions.
Thank you. Please sit down. So, let's see the result. After the collision, the white billboard will stay up. The red one is run away. Why do they change the movement before and after collision? We are going to find the answer of this question. Let's start.
We consider two objects in the collision, so we have the before the collision. Here we have that. We have M1 here, have velocity v1 in this direction, and M2 here has the velocity in the direction. During the collision, we have this, like that, M1 here and M2 here. So finally, after the collision, we have two objects in the different direction. Like that. One here has the opposite velocity, and M2 here has velocity like that. So we observe the velocity change, right? So which is false? Do you please?
Teacher, I think because of course the velocity change.
Thank you, you are right. So do you volunteer to go there to present all the false and different on them? Okay, so let's So then we can see the effect of the force. Is this very right? The forces are according to the first law, the Newton's first law. So we can get the force object 1 plus object 2 equal minus the force object 2 exerted on object 1. Right? So next, we know the cost of change velocity, and we will find the relation of the initial and the final velocity in this collision. I will divide it into 4 groups. And here is our paper, and will write on this. Time's up. Are you finished?
Yes.
teacher.
So I want to a group volunteer to go there and write the answer. So who volunteer?
Group 4.
You please. Yeah.
Teacher, I'm done.
Okay, thank you. And stand there and talk about the answer. Why you have that?
In the second law, I apply the Newton second law. And this line, according to the formula of acceleration. And from this, we can write this line. And transform, we have the five line.
Finish?
Yes.
Okay, so I have two questions. Why we have from this to this?
I don't know.
Okay, thank you. Come back to six. So, who knows?
No.
Okay. So, in this the line have the same interval time, and they are very small. So, why we have that from this to this? And we have learned about the this equal the momentum, right? And we have the momentum 1 plus momentum 2 equal the final momentum 1 plus the final momentum 2, right?
Yes.
So this is the total of the initial momentum before the collision, and this is the momentum after the collision. And we can easily see that P initial equals P final, right? And now to control this law, we will take an experiment to verify it. Oh, hello.
You see the movement before and after collision are equal. To check this equation, we need to do experiment. What we need to experiment? Then, please. Yeah. It's okay. Yeah, we need to measure the luminosity before and after collision. So, it's okay. Yeah, we need to measure mass of objects. It's okay. We need to add more condition for this experiment is eliminate the external force. Okay, so to measure the velocity, we need to measure through the distance x and time t. Yeah, we use the photo gauge. To measure the mass, we need to scale. Eliminate the external force. How we can eliminate the external force? Yeah, we can eliminate the friction force. We use the air trap. To simplify situation, we consider two mass, two cars in linear and one dimension. I will show you I have air tracks with the car 1 and car 2. And car 2 is okay. We have two photo gate. Car 1 goes like this. And photo gate 2. This one and gate 2. Now, this will connect this digital time. We will do with the time of this. It's okay. To simplify situation, we consider object 2 is a graph, which means velocity 2 equals 0. Now we have m1, v1 plus and 2 v2 is equal 0. m1 minus m2 final velocity. Yeah, we have m1, v1, m1 plus m2. After the collision, two objects will stick and move with common velocity v. Yeah, we have m1 over m1 plus m2 equal v2 common velocity over v1 equals s over t. This means t1 equals t1 over t. t1 is measurement by first photo gauge, and the t2 is measurement by second photo gauge. It is common velocity. Yeah, I will consider the case m1 equal m2. If m1 equal m2, we have m1 over m2 plus equal t1 over t2 equals 1 over 2. Yeah. We will check this. I will consider the state M1 equal M2. Now, M1 over M1 plus M2 over M1 1 plus M1 equal 1 by 2. It also equal T1 over T2. To check this, we'll do experiment to find the time over through the photogate 1 over the photogate 2 equal 1 over 2. We will do experiment. Come on.
In this experiment, we have an air shaft, light, two cars, and this, and about the timing device. Two digital timer here and here, two light barriers here and here, and two corresponding supporter and electric hose and plug. Before the beginning of the measurement, spend at least 15 minutes to figure out which external factor can disrupt the motion of the cars on the shaft, and what you should do reduce or eliminate these factors. Remember, the successful completion of this lab strongly depends on your ability to create an almost closed system. Move car on with the blocking plate and to styling plate on to one edge of the shaft, and the same in the car too. Opening, put two gates on the shaft and connect them to digital time and select on the mode timing on. And then we connect the air tap from the air supply to the air shaft, and then the slightly hit car 1 to approve its motion. Observe what happened and read the time indicator on the timer T1 and T in sequence, and then verify the mentioned consequence.
We have to experiment 3 times. 1, 2, 3. We need to measure C1. We need to measure T. We check it, we need to compare 2T, T and 2T1. Yeah, 2T1. And then 30 over T. To see the errors of data. Can you find the data, the table data? You click. So thank you. Yeah, you can see in this, in first time is okay. Yeah, in the first time it is okay. You see the arrows is too small. Okay, so in the second time, you see it shows. Yeah, in the second time, you see the momentum before and after collision are not equal. Can you explain why in this situation? You?
I think we slide rule.
Why slide rule is not correct?
If we slide rule, we will have the friction very big. So we can conservation of momentum.
Yeah, I understand, but I think you so not clear. Yeah, I will show you why. Because in this way you push choose line. So when you do experience, we only eliminate the friction force. We not. In this case, we need to know internal force. Yeah, we need to know an internal force. We only eliminate. So when you push to line, the momentum P and the frictional force will be effect is the momentum. So we need to push higher consideration of momentum. It's okay. In this table, you can see the T approximately. This means T, you can see T1 over T. It's okay. So the lower of the momentum before collision equal the momentum after the collision. You need to do experiment with a T M1 equal to M2 and M1 equals almost M3. I would conclusion the momentum before the collision equals the momentum after the collision. We need to apply the formula for exercise. I will show you some homework. You need to remember formula and do some homework. Take a look 1, 2, 3 in the book. you for watching.